everyone. I think we're ready to start the last session before lunch. I won't make you suffer from hunger for a lot of time, but I don't promise. So anyway, let's start with the talk. We went in semi mocks. That's the title, and you might guess that we're going to talk. Oh, it's loud. Okay, we're going to talk about tests and testing techniques. Testing is a fundamental part of software development with Ruby. I can't imagine writing a Ruby program without writing tests. Well, I can imagine it, but I don't recommend doing this if you want to build something real out of it. So I'd like to start the discussion with a question. And it's not going to be the question, do you write tests? Because I know the answer. Well, maybe my belief is too strong. But anyway, let's move on to the next one. How do you write tests? And by how, I mean which testing style do you prefer? Like according to the theory, there are classical and mock styles. Let's see what does it mean in the Ruby context. Well, given this code example, some method of some unknown object, we do not care about the particular class, which do some searching functionality. How do you write a test for this if you're a classical style follower? It's going to be something like this. First, you define the context, the required context for this method to be executed, and then you assess the return value given the input. If you're the mock style developer, then you first identify the dependencies you have in your method, and you isolate them. You don't want to test the dependencies in this method test. You only want to test this particular method. Okay, let's replace the query and user classes and their objects with some fake objects and just verify that our method uses them correctly, that our method communicates with them correctly. That's just a matter of style. I'm not going to argue which one to use, and that's not the topic of this talk. Luckily, we have great resources and talks on this topic, whether to mock or not. And one particular talk I would like to recommend to check out is the To Mock or Not to Mock by Emily Sam from the last year, RubyConf. And for today, I want to focus only on one but important difference between these two styles. And this difference is kind of based on the way code execution paths are happening within the code base. So when you use a classical approach, every object is real, and code execution paths in your test environment are the same as in your production, as in your running application. So what is a code execution path? It's like a call trace that's which put on the map or something. So we can build a graph of object communication out of it, how real objects communicate to each other. They're all connected. When using mock style, however, we lose this connectivity because every time we hit a fake object, we introduce a gap in our execution path. It's not really an execution path, it's a collection of partial paths. And the communication graph, which could be built out of it, is not connected. It's actually heavily disconnected. Well, such picture is not typical for Rails or Ruby applications. Sorry, Rails, with RubyConf. Okay, anyway. Usually we mix both styles, and actually, from my experience, Ruby developers prefer to go classical and introduce mocks in some places. But even using this mixed approach, we can hit this disconnection problem, like disconnected graph. And it could lead to false positives. So what is a false positive? Given our example, currently our code is working, our test is green. Now we introduce a breaking change to one of our dependencies API. Like we change the argument type, for example, and the code is no longer valid, it's broken, but the test is still green. And we failed to catch the problem here. That's an example of false positive, just one of many. We're going to talk about them a lot today. And the topic of this talk is how to avoid false positives when using mocks, even in a mixed style code base. Or in other words, how to put seams on our communication graph to make it comply with the reality. Okay, a bit of introduction. My name is Vladimir Never Vlad, it's a different thing. And you might have seen me on GitHub as Balkan. I maintain some projects, few, dozens, probably. And I work for a company called Evil Martians. We product development consultancy, helping businesses to grow, And apart from that, we're actually doing a lot of open source stuff, like really a lot. You've probably used some of our projects, at least one of them. And the project I want to separately mention from this long list is TestProf. I started it 5 years ago, time passed. That's how I got attached to testing and doing some Ruby test related research, because I see a lot of code bases and I see a lot of problems which could be typical to many of them. And one of these problems is kind of unsafe usage of mocks. So the talk. Keeping mocks in line with real objects. That could be like an official title of this talk, not just weaving, seaming, something, spiders, whatever. If it's going to be like, a scientific conference. To demonstrate the problem and the solutions, of course, I need some playground. And I chose one of my open source projects for that. That's a library called AnywayConfig. It's a configuration library for applications and gems, which allows you to separate the concept of a configuration object from the configuration source. So you use Ruby objects to represent your parameters, and the library takes care of populating them from different sources. For example, from the environment variables. Here's how it works. It just picks up the matching environment variable, parse them according to some conventions. And that's a particular functionality I want to use in this talk for demonstration. So loading data from env to configuration objects. We have two components which involved into this process. First one is an env parser. That's a component which is responsible for dealing with the actual environment. It describes how to deal with building hashes out of env. And the second component is env loader. That's a plugin, source loading plugin for the library. So AnywayConfig allows you to load configuration from different sources, and every source is backed by its own source loading plugin, loader. So this loader is very simple. It just knows how to use the parser properly. So we have a dependency here. And we have tests. Like I pick up a subsuite just for these two components. It has 100% coverage, and it's green. Great. We're going to use it. My test, I'm more in a classical style, to be honest. So my test looked like this initially. So in order to test the loader class, we actually set up the whole environment, real env object, and use it. But that means that we're actually testing the parser here more than loader, because the logic of dealing with the actual env is the responsibility of another component. Let's rewrite it in a bit of mockist style and test what the loader should do by introducing some fake objects. So let's fake the parser and just make sure that we use the correct API provided by this object to get the data. And that's where we just introduce the possibility of false positives. And the first case for false positives I'd like to talk about here is undefined method. Let's imagine the following refactoring. We decided to merge two API methods into one, like less API methods, better, to not expose a lot. To keep the previous kind of behavior, we added a positional argument. But now we don't have this fetch with trace method. Our test is still the same. We haven't touched it. Because why do we need to touch it if it's still green, right? We refactored our code, the corresponding unit test for our parser, but our test is green, and the coverage is still 100%. The problem is our code is broken. It's no longer valid. That's a double trouble. Why is double? Because both test green and coverage is 100%. It's introduced the fake confidence is that everything is okay, but it's not. Speaking of coverage, let's take a look at it. So we have some historical data for our coverage, and it's all 100% for all the steps. And if we take a look at the particular file which is broken, we can see, okay, the line is covered, but the covered line doesn't mean anything. Like, that's just another example that 100% coverage is not a silver bullet. It's not something you should worry about. So what can we do about it? How to make sure fake objects take care of such false positives? That's a not new question. Actually, I want to go back in history, like 10 years ago, and tell you about the issue open in the RSpec mocks project. So that's, I think, the first time the question was really raised to this project, which led to some consequences, to some features added to the RSpec. So how do we deal with stubbing a method which is not defined, which is missing, which was removed or whatever, or renamed? And the project already exists which solved this problem. It's called RSpec Fire. Of course, it's no longer kind of maintained, its archive project, because it was merged into RSpec. It was merged in the form of instance double. The feature which changed kind of a lot of things, but in this particular case, it fixed our test suite. And by fix, I mean it let it fail when the corresponding dependency changed its API. And that's a simple example of how to make mocks more stable. We already have it, so we have it on RSpec, and Minitest checks for method presence by default when you're using stub as well. So we have different types of doubles. We have just simple double with no commitments, and we have verified doubles. That's a term from RSpec. That's an instance double, for example, which checks for method existence. But that's not the only thing it takes care of. It also helps with some other false positives. For example, when the method signature is not valid. When we call the methods that exist, but we pass arguments that are not acceptable by this method. Okay, let's continue our dangerous refactoring. So we realized that adding some behavior with a positional Boolean argument is not a good idea. It's never a good idea. So let's convert it into a keyword argument, right? That's much better from an API design perspective. Still, our test suite stabs the method which accepts a positional argument. But that's a good thing about instance double or verified double in RSpec. We can catch this problem. So it not only checks that the method exists on a particular object, but also verifies that the past arguments match the signature, kind of. Like signature, I would quote this in this case. A bit of internals just to demonstrate some ideas behind this verification. So RSpec uses message signature verifier, which do a lot of checks and check whether the call is valid. And under the hood, it uses method parameters. That's an example of the powerful Ruby introspection capabilities. So for every given method, we can ask Ruby VM, hey, what was declared in the method definition as parameters? And we can see that, okay, there are required arguments, required keyword arguments, blocks, whatever. So we have the type and the name. And using this, we can check whether the past arguments match the method definition. It works if you have explicit arguments specified, but if you have splats or arguments forwarding from Ruby free, it won't be useful. But anyway, that's much better than nothing. So we have method parameters verification with instance double, verified doubles in RSpec. But I said that parameters is not actually signature. Signature is something more, right? And that's what leads us to the next thing. So signature is not only parameter shape, I would call this, like what method parameters returns. It's also about argument types and return value types. Types are more important, actually, because we need to make sure we pass the right thing to our mocked method. Unfortunately, we cannot guarantee this with the existing tools. Let's demonstrate that. So another refactoring. Previously, we returned an array of 2 values as a result of our fetch method call, which is not, again, a good idea. Let's wrap it into kind of a data value object, struct in our case, with 2 fields, data and trace. And as before, our stop stays the same. And again, our tests pass, and our code doesn't work. The error is cryptic. That's another problem. We pass something incorrect to our method chain, and now we see that, oh, undefined for nil class. Good luck with nil class. So that's a problem that's hard to solve with the tooling which was born 10 years ago. And I want to refer to RSpec Fire again. That's an amazing project with some great ideas. In its README it states, we lost something in translation from typed languages. We cannot verify the contract between a mocked object and a real object. Typed languages. The thing is, today is not 2013, today is 2022, and we have types. So we have types and we can add them to our mocks. Like, not add them to mocks, that's kind of tricky, but we can use them to verify our mocks. Imagine mixing RBS or sorbet into verified double. Some magic, and we have type double, which can verify the method signature, not just parameters. What is a type double? Well, it's actually based on two ideas. We can intercept calls made on mocked objects or fake objects, and we can type check them in the runtime. Both RBS and sorbet provide runtime checking capabilities, so we can use them here. Very kind of a simplified version of it would be just this patch. Luckily, RSpec has a single kind of entry point for intercepting proxy calls. So we can just intercept them and type check. And with RBS, we even have something like type check functionality under the test namespace, which is used for runtime testing, which I used in my example. I chose anyway config not accidentally. One of the reasons was because it has types included into the gem. So I already have my env class covered with types. So I did this patch, and now my tests failing, and that's great. That's what I was looking for. Now my instance doubles. We don't even need to introduce new DSL, API, whatever. We can use RSpec in this example, doubles, but extend their verification with one more step to verify the type signature. That's perfect. That could be the end of the talk. But that's the most interesting part. I doubt, raise your hand if you use types in your applications. Like Shopify, okay. Someone else? Okay. Yeah. I don't want to stop here. I want to bring this power to those who haven't embraced types yet. And that's what we're going to do. We're going to generate our type signatures on the fly and, again, use our type checkers to verify them. So we already have the part responsible for type checking. We already built it. Great. Now we need a way to generate signatures. Let's think about how we can do that. There are some static tools like RBS Prototype or Tapioca for sorbet. We can use Type Profiler. But they're all kind of a separate step tools. They require you to really generate types from something, but we don't want. I want to use only our test suite as a source of truth. And that's a good thing about tests I learned along the way, that tests allow you to analyze your code base much better than anything else because you have a lot of calls executed and all that runtime statistics. So we can use it to generate types. And the process consists of several steps. We need to collect method calls made on real objects. So I'm assuming that you cover your mocked objects separately, so you have unit tests for them. So you perform real method calls. That we can intercept these calls and collect the arguments and return values. How we can do that? There are multiple options. I went with tracepoint for a few reasons. The main reason is that tracepoint doesn't interfere with the object under kind of a tracing. So you do not need to patch it to include something or whatever. You just rely on VM level events. It's not affected everything else. So it's just a separate kind of a process. It's a bit tricky to get argument values from tracepoint, but luckily we already know about method parameters, and tracepoint provide the binding. So we can actually put the past arguments out of the trace point and collect the call trace. So this step is kind of typical. It could be used for many purposes, like tracing and collecting calls. Next step is generating types from these call traces. So what is a call trace in this case? It's just a combination of past arguments separated by positional keywords and return values. So for every tuple, we can generate a mapping of classes used to pass here and just collect the unique for each argument, we collect unique classes and just create a union type in our signature. It looks like this. So this is an auto-generated type signature for our nth class generated by executing test suite for this class, so running unit tests. It's pretty kind of correct. It's 100% correct, actually. It matches the same, the signature I wrote by hand. That's a good thing. We know how to collect call traces. We can generate some dummy signatures. Like not dummy, but valid, but still not automated. The problem is we cannot collect all the possible call traces in our application. You can imagine that, right? Running a Ruby test suite would involve, like, I don't know, millions of calls, like method calls. That's a lot. That would just make your test really slow and unusable. We need to selectively look for only the classes, modules, like objects, let's call it objects, and methods which we used in our fake objects. And for that, we need to analyze which objects are mocked in the test. That's the most tricky part here. And to solve this problem, I went with fixtures. How mocks relate to fixtures, you might ask. There's an interesting article, an idea, actually originally introduced by one of my colleagues. It's available on our website, so fixture-based approach to interface testing. The title is not really clear on what we're going to talk about here, but the idea there is that we can unify using different kind of fixtures, not only for data, like usual fixtures, but only for mocks. And the tool was built called Fixturama, which allows you to define mocks, like to keep a library of mocks, I would say, in YAML files, like fixtures. And then you just load it, YAML, in your test and use it. The good thing here is we have a single place where all the stubs or mocks or whatever defined, and we know that place. We can rely on the fact that we know that place. So I was thinking how to expand Fixturama to do whatever I wanted to do, but I found that YAML is not Ruby, and I don't want to force users of my library or whatever it's going to be to rewrite their encode stubs and mocks into YAML. That's not the best way. I want to be as compatible with the current test style as possible. So I came up with the idea of mock context. What is a mock context? So the idea is follows. You extract as a shared context, like an RSpec. If you're not familiar with shared context, like module which you can include in a test if you're not using RSpec. So just a shared behavior extracted from a test. Mock context is just a shared context with one additional feature. We evaluated this context as soon as it being included in some test. So we know that these mocks are going to be in use. That's an indication. And we can evaluate it and get the information about the object being mocked. The code is like this. It's very simple. We rely on the fact that RSpec keeps track of all the mocked objects in a single place, in the proxies registry. So we use it, and we figure out which objects and methods are being mocked. And then, after that, we set up call tracing just for these objects and methods, and that's it. And that could help us to evaluate the mock against their types. The only change we need to do in our test is that we need to go from inlining our stubs and mocks and using context for that. Finally, since we collect call traces and mocked calls now concurrently, we cannot just verify a mock right at the time it was called, because we might have now call traces for the real object, the corresponding real object. That's why we move the verification to the post-run phase. So we do that after a switch, just a few things. We infer types, we do type check, and we fail if not all type checks passed. The overall diagram is like this. Before I switch into the last part, let me drink some water and let me help you, let me give you some time to figure out what just have happened. Okay, let's move on. Type signatures are great. We can verify that mocked calls satisfy the types for the real objects. But unfortunately, types do not save us from false positives, because sometimes values matter. So I call it like non-matching behavior, which means that for different value, particular explicit values, the return type or return behavior, it could be array as an exception, for example, not only return type, could be different. And in our case, we can introduce it by adding returning nil if prefix is empty. So if you pass an empty string, just return nil. I don't know why. Let's do that. And as always, we keep our mock the same as before. So our mock assumes that an object is returned every time, independently of whether we passed an empty string or non-empty string. There is no difference for the mocked object. And from the type perspective, we also cannot add this difference here. At least for now with RBS, I'm not sure about Sorby, by the way, but we cannot tell if the value of the string is empty string, this particular string, return nil. So we have to use this optional return type because we cannot distinguish between different strings. So type signature doesn't help with this difference. And the only way to enforce the correspondence of the mocked object and real objects is to add some contract. How can we do that? So we can consider mocks actually being a contract. When mock defines which values or arguments are accepted and the corresponding return values, it kind of states the contract. Okay, I rely on the fact that when I give empty string, I have an object, not nil, as a return value. And then we need to use real objects to verify that contract. This contract-based mock verification is not new. Again, we can go back a few years ago and find some projects which embrace this approach with defining verified mocks using contracts. One thing they had in common, which I don't like really, that you have to explicitly define the contract in your place. You use the custom DSL to define the mock and the contract, and you keep them together. And I think that's a lot of work. I want to use my instance double to make sure it's how to verify it, whatever, if that's possible. And that's possible for some cases at least. So we already know how to collect, to get the meta information about mocks. And this information contains also the expected arguments and expected return values. So we can construct, I call it like verification pattern for the mock. And then we can use our real call traces to find the matching call trace. And if there is a matching call trace for this mock, then the mock is verified. If not, then we missed this verification. We do not have a matching unit test which demonstrate that given an empty string, we have a non-nil value. It looks like this. So kind of a verification pattern is somehow similar to a signature, but it uses explicit values and some placeholders for values we cannot match. That's the problem here. Not everything could be compared by value to be used in verification. But in the end, if we do this match in our test suite, we can even catch the problem with the empty string. And it looks like this. So we registered the verification pattern with empty string and parsed as a return value, but we've seen a different one. We've seen that when we passed an empty string to real object, a nil was returned. So that's a broken contract, and that's a failure. And eventually, that's our complete diagram of what we have so far. So we not only type check things, we also add some verification to the actual, to match the actual values and their return types. Whoa, okay. I think the most complicated part has finished. A few things of where to go from here, actually. The current implementation has some limitations. First of all, tracepoint does not test, even without doing anything within tracepoint, but just checking whether the class is, within the hash. It could slow down the test suite drastically. There are alternatives I considered, like module prepend, and I have a version with it. But the problem is that it breaks the method signature, like shape, parameter shape. Because when you do module prepend with delegated to supercall, you usually do some argument formatting or whatever. So the actual method parameters is no longer useful for verification. And it affects the method, the ancestor change. So we changed the object model. That could lead to unexpected effects. Another thing I considered is rewriting the source code. I can do that. We already have transpiler. I have, okay. Probably you'll try to use it too. And it's very robust and can just inject some code into the method to keep track of the calls. And that would make it safe and fast. But that requires some work. The biggest problem with all the contract-based mocks is parallel builds. And I have some ideas how to solve them. First one is similar to what we do with coverage. We can just generate artifacts for every build and have a separate job to analyze collected mocks and real calls, and that's it. That's possible. Because we already deal with types, not real values, we can easily dump it into JSON or whatever. Another thing is we can keep this auto-generated verification patterns and types right in the repo, like just to persist them and use for later calls if they haven't changed, and that's the only option. So that's another option. So that's solvable, but not yet. Finally, as I already said, verification patterns work great for primitive values, like value objects, but for custom complex classes, we still will have to write some code, I think. So the question is whether we should bother with all this machinery at all, or maybe it's okay to have a low chance of false positive and just don't care. That's up to you. I think I had some cases in my life when such false positive led to downtimes. It's a matter of your SLA, whether you can afford it or not. So I think that additional care never hurts. But in general, you can avoid simming by just write an integration test. Yeah, a slower test, but more reliable. Why not? Or, I like this quote from the Active Interactor jam. So it's about coverage and integration tests. Coverage for unit tests, it's like, well, it's okay, but real coverage should be high for integration tests. Otherwise, you can sleep at night. So that's things to pay attention to. So first option, just keep it real, and that's it. But that's not always possible. So again, slow test is a problem. I know that. And using mocks is one of the options could be considered. Another thing, just know your doubles. Know how often do you use mocks object, how many different objects do you mock across the code base. You might be surprised by the numbers. And to help you with doing that, I built a query pattern for syntax tree, which could help you to find all the usages. This is only for our spec for now, of mocked objects across the code base. You can learn about syntax tree in the next talk, and find the pattern in the gist. So one suggestion I highly recommend is fixturizing doubles, like extracting them into just even without using all the things I told you about, extracting them into shared context, keeping a library of mocks. It's really useful to understand how your tests use fake objects. Finally, embrace types. I didn't expect to tell that, actually. But yeah, at least you can come up with a linter tool which makes sure that every object that you stub in your test has a type signature. You don't need to cover all the test suite with types, actually for this particular use case, because you can rely on runtime testing for real object tests and type double for mocks. So that's a good compromise, so something to consider. Finally, where to find everything I was talking about. So I was trying to figure out how to name the gem. No, stop. No, not yet. Don't take a picture. Not yet. Anyway, see mean, we mean, like, no, I was trying to play with this analogy, and I said, mock suing. And I feel like it's too boring, mock suing. And I said, oh, yeah, I know what's going to be the title. Not mock suing, but mock sue. And that's what clicked. So that's where you can find it. We'll be able to find it because I haven't pushed any code and even made it public yet. I gotta do that soon. So feel free to try, give your feedback, make your mocks safe in mocking. Thank you.